So yesterday we talked about how to change fractional exponents to radicals, and that would make us able to work the question. Or it made us able to put the two functions together because maybe they didn't have the same base. Like yesterday we might have had 2 to the half and 4 to the 3/4. You can't put those together because one of them's base 2 and one of them's base 4. But if you turn them to radicals, then you could multiply the radicals together like we did in the previous lessons. Here, we're going to be looking at keeping it in fractional mode because they're easier to do if you can do them with fractions. But I could change this to the cube root of 8, and I could change this to the cube root of 8 squared, and I could work the question. The problem is I can work it faster with powers. So if they have the same base, and you see power rules of they're getting married, they're getting divorced, they're negatives, they're power to a power, we'll try to see what we can do with it. So here is our power rules again. When you multiply, you're supposed to add powers because multiplication's like getting married, right? Married means add. So that means I'm going to do 1/3 plus 2/3 because this is a multiplying problem. Does everybody think that's what you would do? Because if I was saying 8 squared and 8 to the 3rd, wouldn't I add the powers? So I add the powers because it's a multiplying problem because they're getting married and we want to put it all in one bank account. Now remember, when you add powers, it's a little different for fractions than it is whole numbers. Fractions, you have to have a common denominator and you add the numerators only. So 1 plus 2 is 3. Yes, eventually, yes, this turns into 1 because 3/3 divides out to make 1, and I don't need to write a 1, I can just write 8. Now, this next example of a to the m to the n says to multiply the problems because remember when there's a parentheses, it's like distributive. So you multiply the two powers together. So over here, I have 5 to the 1/2, and it's to the 4th. And there's a parentheses between the two powers. So I'm going to do 5 to the 1/2 times 4. Now, to multiply powers, you do not need a common denominator, but you need them both to be fractions. So I'm going to stick a 1 under that 4, so they're both fractions. Now, you have two choices in multiplying fractions. You can multiply the numerators and denominators and then reduce, or you can reduce the diagonals and then multiply. I like reduced diagonals because sometimes you don't have to multiply. For example, 2 goes into 2 one time, 2 goes in 4 2 times. The only number in there that's not a 1 is the 2. That's the answer. That's why I like reducing first. So then you're right, it turns into 5 squared. And 5 squared is 25. So by multiplying my powers together and reducing first, I didn't end up having to multiply by 1. Now, here in this problem, it's showing distribute the power on the outside to everyone. It says AB to the m power means A to the m and B to the m. So you're going to put the power on everybody, and then if any of those powers look like something you could change to a radical and work, you will. So for example, here I have 4 times 5, so I'm going to put that half on both of them. I'm going to say 4 to the half. I'm going to say 5 to the half. Now, that denominator being a 2 means square root, right? So what's the square root of 4? 2. See how I can change that when I work it? Does anybody know the square root of 5? No.
1.
Nah. Actually, it's 2.1 something other. But I don't think we really want to change that because 5 to the 1/2 power is the square root of 5 is not a whole number. So we're going to leave that 5 to the 1/2. But we're going to change this one to the square root of 4 because we can say 2 for that. Everybody see that? So 2 times 5 to the 1/2 is the answer because you can't times those.
Okay. Well,
They're not like bases, so you can't work at that any further.
I was going to ask why that in the forward, but I forgot what square root is.
Right, we're doing square root because we're changing the fractional power to a root if it's one of the numbers off the list. Okay? And then this last one shows that you're going to change this negative power problem and move it down. And so if I change this negative power problem to 1 over 9 to the 1/2, then I can work the problem if it's a perfect number. Is 9 on one of the list?
Yeah.
Then I change it to a root and say the square root of 9 to the 1 power, which I don't really like the 1, is 1 over 3. So the key here is, as you go through these problems, if any number off of any list appears in the question, you might want to change it to a root and do the math for that part. But if there's another part that you can't do that with, you just keep up with it, like that 5 to the 1/2. Now there are a couple more problems on the next page that show another rule that we've learned to use with powers. Is everybody ready to switch? No? Okay. So we're still doing the same rules. They're getting married. We're multiplying powers because there's a parentheses between it. We're distributing the power to everybody inside. We're moving negatives. So what have I not talked about that we've talked about before? Division. All right, so on the next page, maybe we have an example of division because they're getting divorced and we want to subtract powers. That's really important. And then sometimes some of these power problems can have two things. Like this one just multiplied the powers and this one distributed. But you could have both of those things happening in the same question. And so that's really important that you recognize all these different power problems. Now, it's just a little bit different with fractions. It takes a few more seconds to think about how do I multiply fractions, how do I subtract them, how do I add them. But the rules are the same. All right, is everybody ready? So the next one shows the division rule. These powers are being divided, so we think of this like being divorced. And so we're going to subtract those powers. And this particular example I thought was really interesting because they used a letter from the Greek alphabet as the base instead of using like a number or a letter we're more familiar with. They put in the letter pi. Pi is from the Greek alphabet, so when they write their alphabet and they're trying to spell something with a P, they put the letter pi for it. No, they put the letter for the letter P in a word. This is the letter for P in the Greek alphabet. No, but you could if you wanted to. All right, but you have to put the P back at the end. So this is division, so we're going to subtract the powers. The base stays the same. They're both pi, so I can subtract the powers. If they weren't both pi, I couldn't do that. So since they're both pi, I subtract. Remember, subtraction and addition work very similar. You have to subtract the numerators and put it back over the denominator. So that means I'm going to have 2 over 2, right? So it equals 1, so it's pi. So luckily some of these powers work out to really nice numbers. Then you leave them fractions. So this last one shows division with a power on the outside, and then basically you're just going to distribute that power to everybody to see if you can work any of it. And so they gave numbers in this example so we could look at the fact that the denominators are 3, so we're going to be thinking, can I cube root anybody? But I've got to put that 1/3 power on both of them before I start thinking that. So keep in mind, as long as that power is a 1 on the top, you're just thinking the root. Does anybody know the cube root of 5? Does anybody know the cube root of 27? Okay, so that means I'm going to leave this the same on the top, but I'm going to change this to the cube root of 27, which is 3. You're right. So those are the power rules that we learned with whole numbers that were positive or negative, or what we call integers, before. Now we're doing it with fractions. And so as long as we can recognize, is it multiplied for married, divided for divorced, a parentheses between the powers, move the negatives, or distribute your power on the outside to everybody inside, that's pretty much what the rules are. There are about 5 of them. And we've been doing a lot of those rules all along, but now we're just going to be doing it with some fractions. So now what I'm going to do is try to introduce some problems that have more than one rule being used, and maybe sometimes in some of the questions, because most of them are not going to be this simple. And most of them have letters instead of numbers also. But there'll still be a number every once in a while that you might have to put a power on, because maybe it's like 3x squared, and the 3's out there. So let's start off with this one. We're simplifying expressions, or simplifying each number, or simplifying your problem. Anytime they say simplify, that's the key word here, simplify. Anyone who says simplify knows that it means use some rules and get the problem down to less than you started with. So when I look at this, I think no negative power is inside, but I got one outside. What does an outside power make it do? Flip. That's right. So we're going to put everything on the bottom, since everything's on the top right now, and make that power into a positive. So once you do that, once you flip that down to the bottom, then we're looking at the power problem that has the parentheses between it. And what do you do when there's a parentheses between it? Multiply. All right, now we can do that multiplying right here on our problem if we just put a 1 under that 3. Now remember what I said. In multiplying, it is best to reduce the diagonals. Once those 3's divide out evenly to 1, they cancel each other out. So now I've got 1 over x squared. Come out to be something really nice. Mm-hmm. That's right. That's why those negative rules are so important to be done first. So don't I need to flip this one down as well? Yes. So if I flip this one down, that'll be to the positive 1 power, and the positive 1 power in this question goes away. So that basically finishes our question because no one needs a 1 power and the negative went away. So now we're going to look at an example of a division problem. Now with this division problem, let me move that up a little bit. With this division problem, I've got more than one negative. Which one do I deal with first? Yes. Always do everything you can to the inside. So we're going to move that x up. And how many x's do I now have in the numerator? X to the 4th. Well, yeah, kind of. I'm going to take the whole entire problem down, don't I, because it's negative. But the key is I had to move that one up and get these together before I want to move the whole problem to the outside. So now the whole thing is going down to the bottom to become the positive 1/4 power. So there's a 1 on top. And then last but not least, based on our rules, we're supposed to multiply powers when there's a parentheses between them. So that makes these 4's cancel out, and I don't have any power left but 1. So it is 1 over x for the final answer. Now I could have done some things over here earlier. For example, I could have done 4 times negative 1/4 and got negative 1, couldn't I? And then moved the negative down. I just like to get rid of the negatives as early as possible. But you still might get the right answer. For example, isn't 3 minus negative 1 still 4? Even if I don't move the negatives, I still can get the right answer. It's just getting rid of the negatives first means you might not make a math error later. All right, let's look at our next example. So here we have a true sense of that I've got to put that 1/5 on everybody, but are there any negatives I need to move before I do that? No, it's correct. I'm going to put the 1/5 on this because that's a negative number. He don't move. He's not a negative power problem. And I'm going to put the 1/5 on this one. Now those are being worked 2 different ways because one's a number and one's a letter. Numbers, you have to look and see, can you do the root or not? And if you don't know, you have to go to your calculator. So I'm not sure, but I'm pretty sure that in this particular question, let's see if I can move this up a little bit. This is a 5th root of negative 32 that I'm trying to see, could it work? Because if it doesn't work, I'm just going to leave it the way it was. And so that's why I have to put in the 5 in my calculator, then go to the math key and pick the one that has the little X on it so that I can type in the negative 32 and see, is there a 5th root to negative 32? Does everybody agree with that? Anybody else get negative 2? Then over here, this is a times problem because there's a parentheses between them, which is like distributive, and so therefore it makes it like times, and so 5 goes into 15 3 times, so I have y to the third. Any questions so far that you want me to go back and hit something on? Yeah, I'll pause the video for a minute for you to write that down. All right, so in our next question, we have some negatives to deal with. We have a lot of fractions to deal with inside. And we have a power on the outside that's got to be given to everybody. Do we want to give negative 12 to everybody? Okay, so yes, let's deal with all those negative powers. Let's bring them down and get rid of them and make it a little easier math for ourselves. So, no, because on this problem that really will not be necessary because y and x aren't the same basis. You would only want to do that if these were both the same letter. So my suggestion would be don't get any common denominators until you see you're physically adding two things that don't have a same denominator. So first I moved down to 1 6 and made it positive. Now how do I make this 12 positive? Flip it again. So that's going to put the y on top and the x on the bottom. But that makes it to positive 12. Yes, now it's time to multiply each one by the power. So I'm going to come over here and write that separate so I can see it. Well, I'm supposed to distribute this 12 to everybody's powers and multiply. So as I do that, sometimes there's different ways you multiply these. For example, I always like putting a 1 under the number so I can see my diagonals well. Because 6 goes into 12 2 times, and there's nothing left to multiply to the 2 but a 1, so that's y squared. And in our other one, where we got to multiply 2/3 times 12, 3 into 12 will cancel out and make that 4, but then you really do need to multiply the two powers together because you still have two numbers. So the key here is when you're looking at these questions, you may need a common denominator, but you might not, because if you're multiplying a bunch of powers together, maybe those denominators will go away, which is why I didn't get a common denominator up here. All right, so in our next problem, we've got some more negative powers to deal with, and as we deal with these negative powers, I don't have any parentheses, so at least I'm not having to distribute a power out. Looks like I might end up with some getting divorced and getting married problems if I move some things around. So let's see how that works. So first of all, the x's, do they need to move? No? Okay. So we're going to leave the x to the 2/3 on top and the x to the 1/2 on the bottom.
You just flip your y in the half and the y to the fourth. You just swap places for yours.
Yes, you do. You swap places for the y's because they're both negative. So actually, in this case, they're all getting divorced. Everybody agree?
Yeah.
Because they're all division. Division definitely is usually unhappy because it's always a harder problem. So we're going to subtract our powers.
Can't you multiply each one? No. Can you multiply one?
I might need to do some common denominator work and multiply some things, yes. And that's why I wanted to do this question, because in this problem I don't have like denominators. I don't just add the top and put it back over the bottom because they're not alike. So I need a common denominator. And so therefore I look at the first fraction here with 2 and 3, and I think, it sure would be nice if they were both 6. Right? Because that would be what they multiply to give. So what do you have to multiply this first fraction by in order to turn it into a 6 on the bottom? All right, so we're going to do 2 times the top and the bottom and make that 4/6. And what do I need to multiply the 2 by to make it turn into a 6? So we multiply the top and the bottom by 3 and get 3/6. And now I can subtract because I have common denominators, which makes it 1/6. Now, you may look at a half minus a fourth and actually know the answer already, because a lot of times halves and fourths and 3/4 we're more familiar with. I mean, think about it. If you have a half a dollar and you take a fourth a dollar off of it, yeah, well, let's see. We're subtracting now. So, you know, think about it. That's like 50 cents and 25 cents, right? But sometimes you might want to do it with common denominator work also, because you want to practice your common denominator. So what's the common denominator for that? 4 is the lowest one. I could have done 4 times 2 is 8 and used a bigger one, but really 4 is the lowest one. So, because 2 and 4 both go into 4. So I'm not really changing the second one. I'm changing the half to fourths. So what do I need to multiply by? That's right. I need to multiply by 2 and get 2/4 minus 1/4, which is 1/4, which is the same thing if I took a half a dollar and took a fourth of a dollar off of it, because half a dollar is 50 cents and a fourth of a dollar is a quarter, right? And what's a quarter from 50 cents? It's a quarter. A half a dollar minus a quarter is a quarter. 50 minus 25 is a quarter, right? That's what we call 1/4 the fraction, a quarter. So, you know, sometimes you might know that. Just like if I said, what's 3/4 minus a half? Well, if you have 3/4 and you take 2/4 away, because that's what 50 cents is, right? Then you got a fourth of left again. So sometimes people look at these and they think of it as money. I don't know if you do that or not, but if you don't. Yeah, because I mean, a fourth is 25 of a dollar. All right, let's look at the next one. I didn't put as many on this page because I didn't know how much space it would take. And they won't take up the whole page, it's just I didn't want to run into another one. But I think we have a couple of questions left that have a little bit more going on in them than the first ones, because they have something on the outside that also needs to be done once you've done the parentheses problem. So first of all, there are no negatives in this question, so at least that's good. But do I need to put these x's together since I have more than one of them? And how do you put them together? Yep, I need a common denominator because they need to get married and get added together. So I need to multiply the half by 6, he says. Does everybody agree with that? So I can change it to 12 times 6. So that's going to make x to the 6 over 12 plus 5 over 12. I'm not going to rewrite the whole problem there. I just want to write that much of it so I can get that done. How much is that? 11/12. All right. So x to the 11/12 to the 1/3 divided by x to the 2/3 is what I have left now to continue to work on, because all I've done is get my x's married. Now I have power to a power. So in that problem, I need to multiply those two powers together. Nothing cancels in this problem. How do you multiply fractions if nothing cancels? Straight across. 11 times 1 is 11, and 12 times 3 is 36. So if a bunch of stuff doesn't cancel out, you can multiply across, which is what I could have done without canceling. You could always multiply first and then reduce. I just like to reduce first, if I can. And this one doesn't. Now that I've got all that together, I'm going to change the kind of way I'm writing my division, because divided by 2 over 3 could be put underneath, right? And that still shows divided by 2 over 3. And that's a better way to write it than using that division symbol, because we don't have any rules for that division symbol, but we do for fraction bar, don't we? If my problem is being divided, I'm supposed to... All right, and in these problems, you're always going to do the top minus the bottom, because you're not positive which one's really the bigger fraction. It's not like I got a 3 and a 2 and I know which one's bigger. So because of that, I always do the top minus the bottom. If it comes out negative, I'll just put it on the bottom. If it comes out positive, it says what it is. But I've got to subtract, and I need that common denominator again. So what am I going to multiply this problem by? Why? Because that makes 36. Okay, 3 times 12 makes 36. 2 times 12 makes 24 over 36. So this is going to come out negative, isn't it?
Negative 13.
So once I realize it's negative 13 over 36, I change it to positive by moving it down. Because I thought 2/3 might be bigger than the top, but I wasn't sure with the common denominator work beforehand, so I decided just to subtract it in the order it was, and if it came out negative, I'd move it down. Now, if you're really sure which one's bigger, you just could do the bigger minus the smaller and put it back where there's more rule. But if you're not sure, always do the top minus the bottom, and then put it back where it should be because of what sign you get. If you get a positive, it goes back on top, and if it's negative, you move it down to get rid of it. X to the 13, 30 seconds, 36, over 36. So they take a little while. The more rules they put together, the longer it takes to work one of these. So I think I have one more of these. We good to go? Everybody's ready for me to change the screen? Okay. I want you to try this one yourself, and then we'll go through it. So I'm going to pause the video while you try it. Just keep in mind there is one negative in here you want to deal with first. And then it'll be very similar to the rules we've been going through. The only difference is I'm not getting married first in this problem now, am I? I'm getting divorced. But it'll be almost identical to the last problem after you get past that first step. So I'm going to let you try that one.
Okay, yes.
I thought I'd do a couple steps and see if you did that part right, because if you did, then that way you know you're on the right track. Did everybody move the 3/4 down?
Yes.
All right, so they're getting divorced. So 2/3 minus 3/4, you could set it up that way, or you could set it up the other way, because 3/4 really is bigger, right?
Yeah.
But if you don't want to have to think which one's bigger, just do the top minus the bottom. Did you make the common denominator for this 12? So then 3 goes into 12 4 times, so 4 times 2 is at 8. And 4 goes into 12 3 times, 3 times 9, 3 times 3 is 9. So that subtracts and makes a negative number, so it goes on the bottom. All right, so here's where you're at so far. 1 over x to the 1/12 to the 3/2 divided by x to the 1/2. So we good so far? So where are you going next?
Now you're going to times 3 to 3/2 to the 1/12.
And why aren't you doing it to the top?
Because
1
there's
to
no
any
fraction.
power.
That's right, 1 to any power is 1, so there's no reason to put it on 1. But you really are putting it on everybody, right? Okay. Has everybody done that step already?
Yes.
I'll take a minute and do it real quick.
Oh, I put it on the 1.
Oh, it's nothing wrong with
Still wouldn't change.
yeah.
Minus the
Why would you subtract it when you put anything to 1? It's still going to anything.
Anything to the 1 power. You see, 1's already to the 1 power, right? So 1 to the 1 power times 3/2 is just going to keep it 3/2. And but then it's a base 1. So if you multiply a bunch of 1s together, you still got 1. So what he's saying is you don't really need to write it on that.
But if you did, like, would you still subtract it?
No, you're not, because these are like bases.
If you type 1 to the 3/2 power in your calculator, it still gives you 1.
Yeah, it's a number. It's a number. You can't subtract powers when they're not like bases.
Well, that's what I was asking here. What I did, though, Nick, I put the x to the half underneath, and I made that a fraction. Like I put it in 1.
See, I haven't even dealt with the x to half. I'm just trying to work on this part right now. Does everybody see that?
That's why he was asking, like he's still asking.
Yeah, I'm not even talking about 1/2 yet. So has everybody multiplied these two powers together? Has everybody got an answer for that?
3 over 24?
Doesn't that reduce?
1 over 8.
See, you could take this problem and say 3 goes into 12 4 times, right? On the diagonal of 4 you multiply it. Or you can multiply it and get your 3 over 24 and reduce it. 1 8. Okay. Now,
One is on top. So if it's negative, you have to move it to the top.
I don't have anything that's negative. Where you got a negative?
No, once we're talking about the next step.
But the next step is division means put it on the bottom. If you're going to divide by something, don't you put it on the bottom?
We got the right answer. You don't
All right, think of it like this. You've got 24 over 2 divided by 3, right?
Right.
What is 24 divided by 2?
12.
Divided by 3.
4.
Okay, now, what if I put 24 over 2 times 3? What's 2 times 3?
6.
Into 24?
30.
4. It's the same answer we got if we divide first and then divide again. If you divide by 2 numbers, you can say I divided by the product of those numbers. So in this problem, when it says 1 divided by this, it just means divided by both of them. So they're both in the bottom.
Told you, Josh.
They're both in the bottom. Because divided by just means put everything underneath that you're dividing by. So now, let's say you didn't know that for sure. You want to see another thought about that because you didn't know that's what it meant. This is division of fractions. And how do you divide fractions? Is you flip and multiply, right? Didn't that put them both in the bottom? So when you divide fractions, you flip and multiply. So if it says divided by something, it means it's going down. Because to divide by means put it on the bottom. So now I need a common denominator again. So this is going to be 4/8 over 8. And if you, are they getting married, divorced, what?
Married.
Married.
So it'd be 5/8.
5/8. So that's about as hard as they get, really, because there's a lot of math going on in that question.
You give it to us and try on our own.
Almost have it.
I did too. I had
Good.
to the 3. I subtracted.
Yeah, I did.
Well, it's one of the issues that you're going to run into with a lot of this math is that you're just dealing with fractions, and that just makes it more complicated in itself. But then you're also having to think about, am I multiplying, am I adding, am I subtracting powers? Because adding and subtracting, you got to get a common denominator, and multiplying, you don't. So there's a lot of different things going on in this problem that could cause you to miss just a little something. So that's why I wanted to look at a couple that are a little more complicated. All right, this is the end of our notes, I think. Yes. Videos.